One concern to be aware of when using a conventional style shock-absorbing lanyard with two legs is the ability for the lanyard legs to work independently of each other during a fall. That concern is made evident when only one leg of the lanyard is connected to the anchorage point and the other is being stored on the side D-ring. In this case, what would happen in the event of a fall? To demonstrate, we will show a series of tests using a conventional style shock with one leg, another conventional style shock with two legs, and a differential type shock that is designed with two legs that work independently of each other. All the tests are performed with a 220-pound rigid weight, which generates impact forces approximately the same as a 310-pound person. The weight will free fall 6 feet, and we will be measuring the maximum resting forces at the anchorage point and also at the side D-ring if applicable. The first test is with a conventional style shock with one leg. This test is a reference point, so you know how a shock-absorbing lanyard functions and the type of arresting forces and elongation you can expect. The maximum resting force was 808 pounds. Note that nothing was attached to the side D-ring. The total elongation of the shock was 36 1/4 inch. The second test is with another conventional style shock with two legs. Note, this test is showing a second leg attached to the side D-ring. The second leg becomes taut during the fall. Due to the second leg being attached to the side D-ring, it restricted the elongation of the shock-absorbing lanyard, thus increasing the maximum arresting forces. Notice that the shock was not allowed to fully deploy, increasing the arresting forces. The back D-ring maximum arresting force was 1,444 pounds. The side D-ring maximum arresting force was 686 pounds. The total elongation of the shock was 23 3/4 inches. Notice that the leg attached to the side D-ring is bearing the full weight of the dummy, resulting in the worker being suspended sideways. The third and final test is with a differential shock that is designed with two legs which work independently of each other. Notice how the second leg attached to the side D-ring is allowed to move freely, as the other leg attached to the anchorage point is bearing the load. Notice that the shock was allowed to fully deploy, decreasing the maximum resting forces on the dummy. The back D-ring maximum resting force was 840 pounds. The side D-ring maximum resting force was 36 pounds. The total elongation of the shock was 36 1/4 inches. Notice that the leg attached to the side D-ring is still free to move and is not bearing a significant part of the weight of the dummy. It does not matter which leg is connected to the side D-ring. The shock automatically adjusted to the leg attached to the anchorage point. This chart summarizes the last three drop tests. The first drop test gives us a baseline for the arresting forces and elongation of the shock-absorbing lanyard. Notice the differences between the arresting forces and elongation on the last two tests. The differential type shock is the clear winner.